So we have the double integral. This time it's over a general region with y's between x squared and 9. On the low end, y equals x squared. On the high end, y equals 9. And then we have x's between 0 and 3. It's critical to get a drawing of this. We have y equals x squared. That's our parabola. Familiar with that. Then y equals 9. That's our horizontal line. And this is when x is 3. This is the curve y equals x squared. Not that we can't do it the way the problem is posed as a dy dx integral. It's that it's nice they gave you the hint that if you switch limits of integration, you'll find an easier time doing it. So we're going to do it as a dx dy, where we use these horizontal rectangles and move them vertically. To get the volume of the shape. So what we need is the left end and the right end of the rectangle. On the left end, x is 0. On the right end, x is on the parabola. But that parabola has the equation y equals x squared. We need to flip it so that it's solved for x. Take the square root of both sides. We want the positive square root of y. And so our new bounds are that x's go between, on the low end, 0. On the high end, the square root of y. What about y's? You start moving that rectangle from a low point of y equals 0 on the x-axis, and you're done when y is 9. The integral from 0 to root y. The integral from 0 to 9. Now let's take a look at the integrand. X over the square root of 3x squared plus y. We are doing the integral as x first and then a y. So we have to do a u substitution because the degree of the inside is 1 more than the degree on the outside, so to be prime for a u substitution. But let u equal the entire quantity that's underneath the radical, 3x squared plus y. The derivative of that is 6x dx. We need to replace x dx, so we take 1/6 of both sides. 1/6 of du is going to take the place of x dx. So with that, we'll have 1/6 the integral of 1 over root u du. We'll treat that as u to the negative 1/2 power. The antiderivative of u to the negative 1/2 power, we add 1 to that, we get u to the 1/2 over 1/2. All of that is times 1/6. And divided by half, same thing as multiplying by 2. So we have 1/6 times 2 root u. Or these cancel to give you 3 root u. I'm sorry, 1/3 root u. Okay, so we have the integral from 0 to 9. Okay, 1/3 the square root of 3x squared plus 9, where we let x be equal to 0 on the low end and root y on the high end. Be careful with this. Alright. And then we have the y integral to worry about at the end. Okay, so x equals root y. We're going to plug it in. Replace x by root y. If x is root y, we have 3y. Oh, that's not a 9, I'm sorry. Oh my gosh, I keep making mistakes. 3x squared plus y. So we plug in x equals root y. We get leave the 1/3 all the way out. Have the integral from 0 to 9. Okay, so we have the square root. We're going to replace x by root y. We square that, we just get y. So 3y plus y would be what the upper limit gives. The lower limit would give a square root where we replace x by 0. So we get 0 plus y. And then we have the dy integral. Okay, now this first one is a 4y underneath a root that is 2 times the square root of y. Conveniently, this is the square root of y. So 2 root y minus root y, it's like $2 minus $1, you'll be left with $1. 1 root y. So there we have it. We have the integral 1/3, 0 to 9, y to the half dy, which is y to the 3 halves times 2/3 from 0 to 9. We're going to get 2/9 times 9 to the 3 halves minus 0 for the lower limit. And 9 to the 3 halves is a 27. There's a couple ways to do this from here. But we'll just say that we get 2/9 times 27. How do we get to 27? 9 to the 3 halves is 9 to the 1 half, or the square root of 9, and then cubed. So that's a 3 cubed, which is 27. And then we can cancel where the 9 would turn the 27 into a 3 to give us a final answer of 6.